Hello and welcome. In this video I will do the algorithm to convert infix expressions into postfix expressions. Okay, so I already have the code for the main where I ask the user to insert a expression. Okay, I put the expression inside of this char pointer and then I call this function to postfix expression that is empty. Okay, I will do this here. Also, I have a stack that I used in another video, but this stack is a little different. Okay, this stack is a stack for char. Okay, it will have chars. It has the size of 10. The push function receives a char, so it inserts a char in the stack. The pop function will return a char from the stack. Also, we have is empty to know if the stack is empty or not, and we have a top char. This function just gives us the top char of the stack, but don't pop it. Okay, so we can know what is the top char of the stack with this function. So let's go to the code. Postfix. First we need to take a look at the algorithm. First we know that we have to scan every char of the input expression, right? So to do that we go here and we say, let me put this smaller, and we say that for int I equals to 0, and while expression at I is different of end of string I++. So we are, with this code, we are iterating for each char in the string expression I. For each char in the string we will do something. Okay, I almost forgot to declare here the char pointer that is the result, and also we need an integer for the index of this char pointer. After this loop we will say that the result at index is equals to end of string. Okay, and then we will print the string like this, result. Okay, so inside of this for each char in the expression we have to know if it is a operand, if it is a left parenthesis, if it is a right parenthesis, or operator. Okay, here I will say that if is operand, and I put the C here. This is a function that I did not created yet. Okay, else if is operator, and we give it a C again, and this is another function that I did not create yet. Okay, let me put these functions here in a new file so we did not forget to implement it. If it is operand, if it is operator, and also we need to know if it is left parenthesis. Okay, and also if it is a right parenthesis. These are the 1, 2, 3 and 4. Okay, so if it is an operand we will print So we go here to the code and we say result at index plus plus to update the index is equals to C. So this is equivalent of print because I am putting the char in this char pointer that I will print here. Okay, so the first this is done. Okay, let me see easy stuff. This guy push onto the stack, so left parentheses, we just push on the stack. We call stack push C, just that. And what this will do, if we go up, we have this. It checks if it is not full. Okay, it will insert the char in the stack and then it updates the count of the stack. Okay, so we have 2 out of 4 operations done. Okay, the next one is this, the next easiest. If we go here, right parentheses, we will pop and print until left parentheses is found. Then we discard left parentheses. Okay, so going back to the code, we say we need to pop char C pop is equals to stack pop. Okay, we are popping out the character from the stack. Then while C pop is different of left parentheses, while we not found the left parentheses, what we will do, we do a result at index plus plus is equals to C pop, so we are printing. Okay, and then we get another C pop, another char from the stack, stack pop, like this. Okay, if it is the left parentheses, this code will not run, so we are discarding the left parentheses. Okay, so we have this done, and this done. Now the most complex one is the operator. If it is an operator, we will first check if the stack is empty or if it has a left parenthesis on top, so we push. So going back, and we don't need to see this, so here let's declare a char top char. We will need to know to know if the top char is a left parenthesis. Okay, I will do, you can do this in other way, but I will do with a while true, to be more easy to understand. Okay, so we have a cycle because of this scenario. If it is lower or equals the operator from the top of the stack, we will do it again. Okay, so this is a loop while one top char is equals to stack top char. Okay, for each cycle we are updating this top char, and then we will check if stack is empty. If the stack is empty or the top char is equals to left parentheses, we will do something. Okay, in the other case we will do another something. Okay, this rule is this first one. If the stack is empty or stack has left parentheses on top, we push. Go again to the codes. We say that stack push C, and then we will break. The next one is the else. Okay, the else, where we check the precedence rule. Okay, we need an integer for precedence C is equals, to get precedence of C, and int precedence of top char, tc top char, get precedence top char. This is another function that doesn't exist yet. It will return a number, okay? And now we will check if the precedence of C is higher than the precedence of top char. We will do something, and else we will do another thing. If it is higher, we push. If it is lower or equals, we do a pop and print, and then repeat the cycle again. Okay, if it is higher, this scenario, if it is higher, we will stack push the C, and then we will break. Okay, so these are done. Now we need this one. If it is lower or equals, we pop and print and repeat. Char cpop is equals to stack pop the char and result index plus plus is equals to cpop. We don't do nothing more, so we go again to the top of the cycle and do this again until we reach this point. The stack is empty and we return, or the precedence is higher than the top of the stack. Okay, we have this done. Okay, we have these done, and these and these. We must do this last one, expression ended pop and print all operators from stack. Okay, so going back to the code, we know that the expression ended, so it is after the for each char in the expression. We just ended the scan. We will, while stack is not empty, it's not empty because I'm putting a negation here. Okay, stack is empty, not. Okay, we will see pop the char, pop and print our pseudo print equals to C, and that's it. We just need to do this. The expression ended, pop and print all operators from stack. Okay, so what we must do next? We must implement these three functions. Okay, so let me go up, let me put this smaller, and I have this section of code to implement the functions. So if it is an operand, it is true or false function, so its integer is operand and receives a char. Okay, and we have another function that it is another true or false function, so it receives _2 and returns an integer. Let me copy. Get precedence of a _, okay, the value of that precedence thing. So we have three functions that we must implement. Let's focus on the is operand, the easiest one. So if it is a and A to Z letter, so we must return C is highest or equal of A, and C is lower or equal Z. Just that, a letter from A to Z. Okay, so the operand is done. The operator is something that can change in the future. Okay, so result is equals to 0, and here we return the result, and we declare a _ pointer of operators that we have, and it will be plus, minus, times, and we have this, and we have this, and then we have the end of string. Oops. _. And next we will do, let me remove these. Okay, next for each _ in the strings, operators I is different than end of string. We do I++, and we check if the operator at I is equals to C. If it is equals to C, we say that the result is equals to 1, and we break the cycle. So this is it. You just have to do this role to know if it is a operator. Is operator. The next one is the precedence, and I could use this logic, okay, in the precedence, but I think it's more funny to use a switch. Okay, so int result is equals to 0, and then we return the result. Okay, and we have a switch that receives a character, and we have the case for power, and we will increment the result. Okay, and then we fall into the division and we do nothing. We fall into the times and we increment the result, and we fall into the minus and we do nothing, and we fall into the plus and we increment the result. So here I said I thought this is more funny because of this. I'm taking advantage of not using the break. Okay, I'm not using breaks here, so if the _, found here is power, it will increment one time, then increment a second time, and then increment the third time. If it is division, it will increment here and here, or at times it will increment here and here. If it is minus or plus, it will just increment one time. So plus and minus is 1, times and division is 2, and power is 3 because we don't have breaks, so it will fall into the next condition. Okay, this is the get precedence with switch. Okay, let's test this. Let's copy and let's go here to the REPL and let me increment this, and let's see if I did not do something wrong. I have here some case tests. If I copy this, that is complicated, and I run, let's paste, and we have these results. Let me see if the result is the same. So AB minus C, D, E, F division plus G minus times minus H and minus. Okay, if it's the same, let's test this 7 and run it again, paste, and I'm not testing if the expression is well formed. Okay, it's important to say this. A, B plus C times D, E, F, G times plus division plus H and minus. So it's working, and this is it. I will provide the code in the description, okay, and I will also include, like I said, the implementation of get precedence without the switch, like I said before, with the for loop. I will let something like get precedence v2 for you to know that this is a second version of this function. Okay, so thanks for watching, and hope you like it.